In section 3637, we're going to identify and write equations of parallel and perpendicular lines. Remember that parallel lines have the same slope. So if you're given two lines and asked, are the lines parallel, we're looking at the slope. These are in slope-intercept form, y equals mx plus b. So for number 1, line 1, my slope is 1/2. For line 2, my slope is also 1/2 because those are in the location for m. They're next to the x. So yes, these lines are parallel because the slopes are exactly the same. The sign is the same, the numerator and the denominator. Number 2, line 1 has a slope of -2. Line 2 has a slope of +2. Because one is negative and one is positive, these are not parallel. We're also going to be writing equations of lines, just like we did in section 36a. For this number 1, line 1 is y equals -1/3 x minus 1. Line 2 is parallel and passes through the point 3, 2. If we want to write an equation of a line parallel to line 1, we need to use their slope, because parallel lines have the same slope. We're not going to use their intercept, we're going to find our own. So we have a slope of -1/3, and that this passes through the point 3, 2. Using this information from the problem, we're going to do the same method that we did in 36a. You can either use slope-intercept form, y equals mx plus b, or point-slope form, y minus y sub 1 equals m times the quantity x minus x sub 1. Plugging into slope-intercept, the y value from the given point is 2. Our slope is -1/3. Our x value from the given point is 3, but since I'm multiplying by a fraction, I'm going to put 3 over 1 plus b, because the intercept is what we're trying to find. The 3's cancel, so we have 2 equals -1 plus b. To get b by itself, we need to get rid of the -1, so I'm going to add 1 to both sides, and b is 3. Remember that to write your final answer, you need the letter y, the letter x, your slope, and your intercept. So our slope is -1/3 because we want it to be parallel to the first line and have the same slope, and our intercept is 3. You could also solve this using point-slope form. The first y stays a letter. The y sub 1 is where we plug in the 2 from the point. Our slope is -1/3. The first x stays a letter, and the x sub 1 is where we put the 3 from the given point. To solve, because I need all of my answers left in slope-intercept form, we're going to distribute. So we have -1/3 x. Our -1/3 times the -3. Negative times a negative is a positive. The 3's cancel, and we get +1. To get y by itself, to leave our final answer in slope-intercept form, we're going to add 2 to both sides, and we have y equals -1/3 x plus 3. And you could use either method you would like. You do not have to use both. Number 2, line 1, the line that you're given, is y equals 2/5 x plus 3. Line 2, the one we're trying to write, is parallel to line 1 and passes through the point 10, 6. Because it's parallel, we want to have the same slope, so we're going to use a slope of 2/5. And we're going to pass through the point 10, 6. I'm going to solve number 2 just using slope-intercept form. If you would like to use point-slope form, the y minus y sub 1, go ahead and solve using that, and let's see if we get the same answer. So to solve this, I'm going to use y equals mx plus b. The y value from the point is 6. M, our slope, is 2/5 because we want to be the same as the first line. The x from the given point is 10. And because we're multiplying by a fraction, I'm going to write this as 10 over 1 plus b. So we have 6 equals, and if I reduce 2/5 times 10, 5 divided by 5 is 1, 10 divided by 5 is 2. So 2 times 2 is 4. The ones on bottom could just drop out, plus b. To get rid of the 4, we're going to subtract. We get that b, our y-intercept, is 2. So our final answer is y equals 2/5 x plus 2. Just like we did in section 3.6a, writing the equation. You need to know that if it's parallel, you're going to take the slope from the given line and use it along with your given point. Go ahead and try number 3. Line 1 is y equals negative 4x plus 3. Line 2 is parallel and passes through negative 2, negative 1. Pause the video and try number 3. I'm going to solve this using point slope form. And if you like the slope intercept y equals mx plus b better, you can use that one. Because we want to be parallel to negative 4x plus 3, what we're wanting from that line is the slope. We do not need their y-intercept. So we're going to use the slope of negative 4 and our given point negative 2, negative 1. So my equation, and again, if you want to use slope-intercept, that's fine. Let's see if we get the same answer. So I have y minus y sub 1 is the y value from the point. It's negative 1. Be careful that you get the minus from the formula and the negative that's in the point. Equals our slope, negative 4, times the quantity. First x stays a letter, minus my x sub 1, my given x value from the point is negative 2. I'm going to go ahead and change all of my minus and negative to plus a positive and distribute. So we have y plus 1 equals negative 4x. This right now is a positive 2, so negative 4 times positive 2 is negative 8. And to get y by itself, we're going to subtract 1. So we have y equals negative 4x. This is plus a negative, so we have minus 9. Even if you solved using the other method, you should have gotten the same answer. Vertical and horizontal lines are perpendicular, so anytime you have a slope of 0 and a slope that's undefined, those are going to be perpendicular. Perpendicular lines have slopes that are opposite reciprocals. Remember, you need to have opposite signs. One is positive, one is negative, and they're reciprocals. One is flipped over from the other. These examples say, are the lines perpendicular, yes or no? So for number 1, our slope 1 is 2 over 3. Slope 2 is negative 3/2. So I notice that the first one is positive, the second one's negative. That's the opposite part. The first is 2/3. The reciprocal of that is 3/2. So yes, these are perpendicular. The two slopes are opposite reciprocals. For number 2, slope 1 is 4. Slope 2 is 1/4. Even though those are reciprocals, they're both positive. They're not opposites, so our answer is no. Number 3, the first slope is negative 1/5. The second one is negative 5, which is negative 5 over 1. Again, even though those are reciprocals, our signs are the same. They're both negative, so this one is also no. Number 4, our first slope is 4/5. Our second slope is negative 5/4. I notice the first one is positive, the second one's negative. The first one is 4 over 5. The second one is the reciprocal, 5 over 4. These are opposite reciprocals, so yes, they are perpendicular. You may be asked to see if lines are perpendicular based on a graph. You can either count the spaces on the graph to find the slope of each line, or you can use your formula for slope. I'm going to start by finding the slope of the blue line. If I were to count, remember we do rise over run. So I'm going to start at 1, negative 4 and count to the point 4, 2. So to rise, we're going from negative 4 to 2. So I'll go 1, 2, 3, 4, 5, 6. So we're rising 6. And then I'm going to run from the 1 to the 4. So 1, 2, 3. 6 divided by 3 is 2. So the slope of the blue line is 2. We're going to find the slope of the line that I left green, doing the same method, rise over run. And again, you can use your slope formula. I'm going to count the rise from -1 to 2. So 1, 2, 3. And the run from 5 to -1. 1, 2, 3, 4, 5, 6. 3 over 6 reduces to 1/2. These are reciprocals, a positive 2 and a positive 1 over 2. And on the second line, the green line, when we count up, that's a positive. When we count back, that's a -6. So in addition to being reciprocals, 2 and 1 over 2, these are also opposites. 2 is positive and 1/2 is negative. So yes, these are perpendicular. Remember that if you count up and to the right, that's a positive number. Down and to the left is a negative. The next section says, are these lines perpendicular? And you're given the equation of the line. We're going to find the slope and compare those to see if they're opposite reciprocals. Number 1, this is in y equals mx plus b, so my slope is right next to x. The slope of line 1 is -2/3. The slope of the second line is positive 3 over 1. These are opposites, one's a negative, one's a positive, but they are not reciprocals. The reciprocal of 2 over 3 would be 3 over 2. So no, these are not perpendicular. For number 2, the slope of my first line is a positive 5 over 1. The slope of the second line is -1 over 5. Because one is positive, one is negative, and they're reciprocals, 5 over 1 and 1 over 5, yes, these are perpendicular. Number 3, the first line is y equals -2/5 x minus 3. So my slope for that line, this is still y equals mx plus b, slope-intercept form. So the slope is -2/5. The slope of the second line in the same form is 5 over 2. Because one is positive, one is negative, and they are reciprocals, yes, these are perpendicular. The lines in number 4, these are not in slope-intercept form. These are in standard form, ax plus by equals c. And we have two methods for finding slope from this form. So I'm going to start with the 4x plus 5y equals 2. I'm going to put this in slope-intercept form by solving for y. So we're going to get y all by itself. We're going to start by moving the 4x, so minus 4x, and subtract 4x from the other side. Then we would have that 5y equals, and you could write down 2 minus 4x, but we usually put the x up front, so -4x, and this 2 is just sitting there being positive. To get y by itself, we're going to divide by 5. Remember, every term, everything that's separated by an equal sign, a plus or a minus, gets divided by 5. So our slope for the first line is what's left sitting in front of x. It's -4/5. There's also a shortcut method from standard form. You take the opposite of a and divide it by b. A is always what's right in front of x, so the opposite of 5 is -5. B is what's right in front of y, including the sign, so I get +4. So we have a -4/5 x and a -5/4. Even though these are reciprocals, they are both negative and not opposites, so no, these are not perpendicular. We'll also be writing equations of perpendicular lines. We'll be given two lines, so we're told that line 1 is y equals -2x plus 1. Line 2 should be perpendicular to this and pass through the point 4, 0. First thing we're going to look at is their slope. Their slope is -2, but we want to be perpendicular to that. So our slope is the opposite reciprocal of theirs. Since theirs is negative, ours is positive. They had 2 over 1, so we're going to use a positive 1/2. We do not need to worry about their y-intercept. It's not needed. Our line is going to pass through the point 4, 0. So I'm going to go to the next slide and use the slope of 1/2 and the point 4, 0 to write the equation of a line. I'm going to do this using both methods. You can pick the one you like best. So we'll use slope-intercept, y equals mx plus b, and point slope, y minus y sub 1 equals m times the quantity x minus x sub 1. To use slope-intercept, we're going to plug in our y value. Y in our point is 0. Our slope m is 1/2. X from our point is 4 plus b, because the y-intercept was what I'm trying to find. Multiplying the 1/2 times 4, half of 4 is 2, plus b, and to get b by itself, we're going to subtract the 2 from both sides. 0 minus 2 is -2. Remember, using this method at the end, you need to go back and write your final equation with your slope 1/2 and your y-intercept -2 plugged in. Using point slope form, the first y stays a letter, minus, remember that this y sub 1, that's where we plug in our y value from the point. So there's my 0. M, your slope, is 1/2. The first x stays a letter. The second x, our x sub 1, comes from the point. So that's 4. Y minus 0 is just y, so you can actually drop the 0. And we're going to distribute on the other side. We'll have 1/2 x minus half of 4 is 2, and we do arrive at the same answer. All of your equations for lines need to be left in slope-intercept form, y equals mx plus b. Let's solve one more, writing the equation that's perpendicular. Line 1 that we're given is y equals 2/5 x plus 3. Again, we're not going to worry about the y-intercept. You can mark that out. We are going to use their slope. We want our line, line 2, to be perpendicular to this and pass through the point 10, 6. Perpendicular to 2/5 would be a -5/2, and it passes through 10, 6. Using slope-intercept, y equals mx plus b, our y value is 6. M, our slope, is -5/2. X is 10, but since I'm multiplying by a fraction, I'm going to write 10 over 1 plus b. If we multiply -5/2 by 10, the 2 divided by 2 turns into a 1. 10 divided by 2 is 5. So we have 6 equals -5 times 5 is -25 plus b. To get b by itself, we're going to add 25. And b is 31. Remember, you need to go back and write your final answer, your equation. Y equals -5/2 x plus 31. Your final answer should have the letter y, the letter x, your slope, and your y-intercept. Using point slope form, the first y stays a letter. The second one is 6, the y value from the point. Our slope is -5/2. The first x stays a letter, and the x sub 1 is the x from the given point, 10. So y minus 6 equals, and we're going to distribute, we'll have -5/2 x. When we multiply this negative times the minus, turns into a plus. 5/2 times 10. If you reduce, you'll get 25, because 2 divided by 2 is 1, 10 divided by 2 is 5. Or you can multiply across, 5 times 10 is 50, over the 2 on bottom, and you'll still get 25. If we add the 6, you'll get the same answer we did for the first one. I'm going to write this at the top. Y equals -5/2 x plus 31. When you return to class, we'll be working in both sections, 3-6 and 3-7. For 3-6, we'll be on page 168 through 171, 11 through 22, 24 to 44, 59 to 73. And at 3-7, we'll be on page 175 to 177, 7 through 32, 38 to 41, and 47 through 50.